Richard Mansell, Chief Executive Officer and co-founder of IVO Limited, delves into the company's groundbreaking endeavor to discuss how the company is working on new all-electric thrusters called the IVO Quantum Drive that drives limitless power from the sun. Join us as we get rebelliously curious. Richard, thank you so much for joining me on Rebelliously Curious today. It's a delight to have you, and I'm excited to talk about IVO Limited and what you're doing with the company and where it's going to be going.
Well, thank you very much. It's nice to join you today. I've enjoyed watching your past podcasts, and you've had some very interesting people on there. And so it's quite the privilege to be a part of this today.
I really appreciate you saying that. Thank you. I did see this quote that you have on the website, and I think it's on your about page, where it says, "Our ambition is to not only push the boundaries of modern technology, but also to place the inventors and innovators and inventors into an atmosphere where the impossible can be possible," which I think is really beautiful. Can you explain a little bit about the mission of IVO and how that statement plays a part of the company?
Yeah, we need companies and individuals today that are in an atmosphere and a company where they can take some risks when it comes to technology. There's a lot of good work being done in technologies and basing off of past work, making things more efficient, making LED screens, even better, making rockets more efficient. There's a lot of work being done improving upon current or past technology. The riskier part is really branching off into new areas. And I think there's a lot of smart men and women out there that don't necessarily have the liberty for financial business reasons. I get why, but they don't have that liberty to just really venture out and try, from a financial perspective, a little riskier, but very exciting technologies. And so one of the things we want to try to do here at IVO is, when someone has an idea and saying this might be possible, we want to be able to put some of our resources towards that and try it out and try to fail as quickly as possible. Like, if it doesn't work, let's find out as fast as possible and move on, but at least still have that chance. Like my COO, Dan Telehay, said, we need more companies like this out there that are just willing to push the boundaries and go for it.
Yeah, I agree. I think that's amazing because we don't have a lot of companies in science or technology that always want to push the boundaries or sometimes go against, what we would consider as mainstream science or mainstream technology, or think outside the box with additional theories that might be something that we could actually become plausible and not pseudoscience.
Yeah, so kind of like, I apologize. Some companies they'll be working on, they'll do iterative changes for a product. We kind of take that mentality to theories, do iterative changes of theories, and go ahead and fail at a number of theories, but let's push the boundaries and see what works and iterate as quickly as possible until we do find the ones that do work instead of just operating in that safe space. And so we try to take that iterative changes and testing that are used usually with a product and apply it to theories and science tech.
Yeah, and being innovative, extremely innovative, and thinking outside the box and looking at somebody's theory and saying, maybe this is possible. Let's give it a try. You don't know until you fail, or you don't know until you actually try to do something. So I respect that immensely. And I know at the debrief, it's very similar to the type of articles and news we share related to, like, we always joke around calling it mad science or things like that, but it's not. It's thinking outside the box and being rebelliously curious, hence the
Yes.
name of both, the debrief's motto and along with the show, and looking and having the ability to hopefully innovate and innovate for future generations. I have seen these wonderful headlines that have come out where recently you've had headlines say new all electric thruster draws limitless power from the sun. And there's something that you're creating called the IVO Quantum Drive. Can you
Yes.
explain, yeah, what the IVO Quantum Drive is? And then how are we powering this with limitlessly from the sun? Like, I think it's unbelievable. But I would love first to start off with what is an IVO Quantum Drive?
Okay, so the IVO Quantum Drive is an all-electric thruster specifically for space applications. And so it's a way to be able to move satellites, probes, spacecraft through space, but without a projectile, no mass ejection from the device. Now, of course, so it's an all solid state device, but a lot of people immediately say, well, that's impossible because you're breaking Newton's laws of motion. And we can go down that road a bit more, because the reality is that we're not breaking any of his laws. And a lot of people will focus on that third law of for every action, there's an opposite and equal reaction, where we come at it from the first law. An object at rest tends to stay at rest. An object in motion tends to stay in motion. And so the reality is, if you can get an object to no longer want to stay still, then it will move. And that really comes down to a fundamental understanding of what is inertia, because that's what we're talking about, is inertial mass. And so several years ago, we were in my personal just curiousness of like, well, what if we're wrong concerning gravity? Not greatly wrong, but slightly wrong. Like going back to Newton, he had gravity pretty much figured out and he made great progress. But then later on, we found out that he wasn't wrong as much as it was incomplete. And so scientists have been able, especially Albert Einstein, have been able to expand upon that. Likewise, I think the same thing with inertia is that Newton's laws of motions and the things we know about inertia haven't been wrong as much as they're not complete. And we're still expanding upon that. And so in delving into that aspect of what is gravity, found out that we really have a lot of unknowns concerning what is inertia. Why does an object at rest tend to stay at rest? Why does it stay in motion? And the reality is everything's actually in motion, right? So from someone's perspective, it's in motion. By its own perspective, it's never in motion. So it really comes down to reference frames, which we could delve into later. But the point is I realized that we had a lot to learn still about inertia. What is inertia? And so where our company has pushed the boundaries is exploring what's the practical application to a more complete understanding of inertia that still fits our current laws and understandings of the universe, but fills in some more of the blanks. And that's how, through that study, just my personal study, got to know Dr. Mike McCulloch out of Plymouth, England, and his work with quantized inertia. And that's what then led into what's a practical application of this theory. And experimenting from there led us to having now this solid state electric drive. And it's not magic. It's not perpetual motion. It has to have energy. It has to consume energy to produce a propulsive force. And so when we talk about from the sun, we're just talking about from solar panels. And so this could be from a thermonuclear reaction as well. Anything that produces electricity could then provide the energy needed for the quantum drive to provide propulsion.
Yeah, you bridged into so many things. I think you answered so many of my questions, and thank you for that too.
Okay.
Because I was going to get into quantized inertia because I was reading about it as well because the people say that it is a pseudoscience, theory, which you guys are looking at and hopefully putting into practicality. How do you get to quantum inertia then to quantum drive?
Yes, great question. And really, other individuals like Dr. McCulloch would be able to get into the details even more so as far as the theory side of things. I'm a very practical person. I like to see what actually works in a test chamber. And so the theory, I'd say I understand some of it, but not on the level of some of the others. But I appreciate it because my response earlier was very high level, so I don't mind drilling down farther into each of these. But it's kind of based on the idea, why does an object want to stay still? Is it because nothing's acting upon it, or is it because it's being acted upon from all sides? And so currently we have more of this idea, mainstream science seems to have this idea that an object at rest tends to stay at rest because nothing's acting upon it. Quantized inertia comes at it from the perspective that an object stays in its current state because it's being acted upon from all sides at the same time. So it's kind of like, if I was standing in the middle of a room and there were 4 people, front, back, left, and right, and they're all stiff arming me. And I'm not going to move, not because nothing's pushing me, but rather because I'm being pushed on all sides equally. So I stay still. However, if that changes on one side or the other, if someone pushes on one of those individuals, then that will push me forward. But the person that's pushing back will still be pushing back. And so there'll be that initial inertial force pushing back. And that's where we get our inertial mass force from. And Dr. McCulloch brings this from the Heisenberg principle, uncertainty principle, and the idea of the quantum foam out there, that we have these frequencies which manifest themselves as UNRA radiation. But you have these various frequencies of different lengths, with the maximum being the cosmic horizon, or the farthest that you can get information from. Any piece of matter can only have information as far as it can see, as far as electromagnetic or quantum radiation. So the idea then is, if you have an equal amount of that information from all sides, then you will stay still. There'll be no acceleration. But if you can dampen the waves on one side, or provide a horizon, as he calls it, on one side, then you'll have fewer frequencies. You'll have less force on that one side. You've now dampened the inertial force on one side, and now that object will want to, if I may, fall in that direction. So what we've done is, in a very practical way, through a physical setup, configuration of materials, and then applying electrical energy, we can dampen the inertia, the UNRA radiation on that one side, and make that object essentially fall forward.
Can we explain? Because I think it's really great because people are like, there's so many theories going on, and they're like, for them, what does this visually look like? Like, what is this made of? When we think of drives, we actually probably think of hard drives. I would think most people, depending on your understanding of technology, when you're watching this podcast or listening to it. Can you explain then, like, how this drive is manufactured? And I believe now you're actually working with SpaceX and have sent it to space just recently. But let's talk about just the physicality of it and the practicality around that, and then how you've made it tangible.
Yeah, so this here is an engineering sample of one of our 1U drives. And so when I say drive, I just mean a device to propel an object through space. Normally a drive, whether it's an ion drive or a chemical drive, it will have a nozzle, something from which to expel mass. And so as it expels in one direction, the object then wants to move in the other direction. Ours does not have a nozzle because there is no mass ejection. Instead, we use our configuration of electricity to change the inertial force on the inside of the drive. And because of it, the drive then falls in that direction, or it wants to move in that direction. And by doing so, it pushes whatever it's attached to, i.e. the satellite. So that's what I mean by a drive, is just something to propel something else through space. The physical configuration is a delicate balance at this point, because we have to be careful what's proprietary and patented and what is public knowledge. And so if you really want to dive deep on this, okay.
Well, I think it's really interesting that we're looking at look how small that is too. It's so, if anybody's watching this, if you're listening to it, it's not very big. It's like the size of like half the size of a little shoebox, let's just say, or like a hard drive. It's the size of a hard drive. It's not very large. So the mechanics behind that in thrusting something is unbelievable. It's just, as they would say, size matters, but in this case, it doesn't.
Yeah, because please understand, there's not a lot of force here. To give you an idea, and your listeners a relative sense of force, is we measure force in newtons. Okay, so this isn't the acceleration of meters per second. This is the actual force being produced. And like to get a Jeep, I think to get a vehicle like a Jeep up to 35 miles per hour, it takes like 11,000 newtons. I could be wrong on that, but it's thousands of newtons of force. In space, though, you can move an object the weight of a Jeep with millinewtons, or a thousandth of a newton. So, for instance, the Dawn spacecraft that went to explore the asteroids, got to 2 asteroids, had thrusters that were 92 millinewtons of force. And to give you an idea of how much force that is, that's like the weight of 2 Snicker bars sitting on the palm of your hand.
That's unbelievable.
Right, because in space, it's the inertial mass you're trying to move. You're not pushing it against gravitational mass. And this is why the inertial mass versus gravitational mass, the difference becomes so important in space. And the fact that we know that there is a difference, even though they tend to be very similar. But there is a difference. And so by focusing on the inertial mass, you only have to overcome that inertial mass, the inertial force, in order to move something. So we're talking about very, very small amounts of force. This little drive here produces 1/4 of a millinewton of force.
Wow.
But since it's only pushing a 3U satellite, so we're talking around 4 kilograms, it doesn't need a lot of force to be able to produce noticeable differences. So we've tested this on Earth in vacuum chambers in as many environments and variables as we could. And we've really come to the point where it has to go to space to be tested next. And like I said, we like to push theories as fast as possible. And this launch really is it's a test to see, all right, it seems to work here. How about in space? But the force is so small that space is where we can really make very clear distinctions with very small millinewtons of thrust.
Can you speak a little bit about what you're doing in space and with SpaceX? Just because people are probably wondering what that relationship is. And I thought I read that you've launched already, but I don't think that's happened yet from what I've seen or what I'm hearing now. But a little bit about that SpaceX partnership and what data and what you hope to find and what you hope to accomplish.
Sure. First of all, we do not have a direct relationship with SpaceX or NASA. I know some people are out there talking about how we've teamed up with SpaceX and Elon Musk or NASA, and that's not the case. However, SpaceX has provided the launch vehicle. So it's going up on a ride share. And so that's our connection with SpaceX at this point. As far as official, we are teamed up with Rogue Space Systems out of New Hampshire, and they're the ones that have allowed us to become a payload on one of their satellites that has one of their payloads as well. So our direct connection is with Rogue Space, and they have been fantastic. They're another company that's willing to try out stuff. And they're like, all right, Evo, if this works, that's great. It'd be fantastic. If it does, I mean, either way, we'll provide an opportunity. So that's where our official cooperative work is with Rogue Space. We were supposed to originally go up on Transporter 8 here in the month of June. However, we ended up taking it off the Transporter 8 rocket because we had been made aware of the possibility that one of the satellite bus components might not work the way it was supposed to once it was in space. So none of Rogue's stuff, it's not our payload. It didn't have anything to do with Quantum Drive. It was just that there's another part of the satellite bus that there was a possibility of it not working. We appreciate our partners in the industry that provided the parts working with us, providing the QA, that they caught this and were willing to, say, all right, let's take it off, let's double check it and put it up on Transporter 9. So currently, the Quantum Drives are healthy and they are awaiting integration for Transporter 9, which is at this time net October 2023. So that's where we're at this point.
Okay, that's awesome. So not too far away.
Yeah, it's a little discouraging to have to wait a little longer, especially since I know so many people are waiting for this to, well, some people are waiting for it to not work, and some people are waiting for it to work. And me, I'm waiting for results. That's really what we're about, is looking forward to results, because this the satellite has 2 drives on it, partially for redundancy, partially because once you have more than one drive, you can do some fun things with it when it comes to maneuvering in space. And so the goal is to have it launch now October 2023. And after the initial LEOPS, time of just the satellite getting situated, making sure its batteries are full, it's operating properly, then we're going to be taking turns with Rogue Space of testing our payloads. So us testing our Quantum Drive, them testing their parts of the satellite as well. And so they're actually going to go first. So don't expect any results immediately, in October, because one of the reasons why we wanted them to go first was because we wanted the satellite to go in orbit for a couple weeks. So we'd have a really good baseline of what the background noise is when it comes to the orbit. Because, as I'm sure there's a lot of things that affect orbit. It's not a nice clean circle. Different parts of the world have a little bit stronger gravitational pulls and affect the orbit. And so we want to have a really good baseline of data set up so that when we turn on the Quantum Drives in space for the first time, if we see acceleration, we want to be very confident that it is acceleration being produced by the Quantum Drive and not something else.
Can we speak about that too? What's powering it? What's its propulsion system?
Yeah, so it has solar panels and a battery system. So it's just using the solar panels to collect the sun's energy, storing it in the battery, and then using the battery to power the drives.
And so then how are the sun would be then, forever, obviously, hopefully powering it, but are there backup systems to it? Like what does that look like? Like what happens if the system then potentially maybe, isn't being powered or a battery does die to it? Is there a backup that might happen on the drive?
No, the redundancy is within the power systems itself, because like I said, it needs power to work. And so as long as it has electricity, then it can work. Now, the nice thing also is these things are very low wattage. So we're talking less than 1 watt. Again, because we're not pushing the object as much as we're wanting it to fall forward. And you can make very large objects fall. Once they want to fall, they can move. And so it's not like we're pushing it through space as much as we're making it fall. So it needs very low wattage. And so it doesn't need a lot. In fact, the solar panels could fail and the battery systems could operate it for quite a while still.
And this has like a really low carbon footprint. And I would imagine that's one of the goals the company has, is to lessen that carbon footprint, and hopefully other companies will follow as well.
Yeah, in so many ways. You're like, well, it's not replacing rockets to space, which, use quite a bit of chemicals. But the thing is currently The lifespan of a satellite, depending on its design, can be anywhere from 5 years to 25 years. Some more, but a lot of them are around that 10 to 15-year period, which means then you have to replace them. And the reason why you have to replace them is because they run out of fuel. In other words, they're still fully operational, but they run out of fuel. And
Right.
so there are some companies that are working towards refueling mechanisms, which I think is a fascinating way of taking care of that issue. But you still have to launch another rocket to get the fuel up there, or you have to launch another rocket to replace that satellite. If the satellites didn't run out of fuel, then they would have much longer service life, would not only save the companies money, but it does mean fewer rockets being launched. For instance, the Dawn spacecraft I mentioned earlier, as far as I know, it's still fully operational. Like all of its science instruments and stuff are, it just ran out of fuel, and so they had to stop using it. And that fascinates me because there's so many satellites. I want to say there's something like 500 satellites that are going to have to be replaced or refueled within the next 5 years.
Wow.
Something like that. I could be totally wrong, but the point is that companies like SpaceX, they now have a fleet, over 4,000, and they want to go even more than that. Well, those satellites have to be replaced. I think they're looking at around on average around 7 years have to replace each of those satellites. So you're talking about each of them being replaced. You're talking about a launch a week just to replace the current number. Now with Starship, that will change it, but you're still talking about more and more launches. Well, if you don't have to worry about fuel, then there's fewer launches.
Right. And it almost defeats the purpose too of what SpaceX is trying to do. I understand they're using reusable rockets, which are amazing. Like they're unbelievable when you watch them land. I think what Elon's doing that and SpaceX is doing is something that we've obviously never seen before and will change the way that space travel happens. But you're right. If you have to launch something every week, you're obviously saving on reusing your rockets and it's cost efficient, but you're still putting so many emissions into the atmosphere. So why not look at something this and everything that you're using have a low carbon footprint for every single thing that's related to space?
Yes, indeed. In fact, we are just on the beginning, the starting edge of using this kind of technology in a practical way, this theory in a very practical way. What if it could lead to actually not only going against inertial forces, but what if we're able to get it to the point of going against gravitational forces as well? I'm not saying that it does that at this point. I'm just saying that if we could get to that point, then we're talking about launches without having to use chemicals at all. It would be essentially space elevators. You just send it up.
It's amazing. How close in practicality do you think that could possibly be? Like just, I know it's like a hard question. It's a hard question to answer too, because it is a theory. Yeah.
Because here's the thing, there's very few of us working on it right now. Very few of us. And I only know so much. There are a lot smarter men and women out there that once they start working on this, I'm sure it will accelerate the pace of developing this technology. But if you start off with the mindset that from a theoretical standpoint, a physics standpoint, it just does not work, it cannot be, then you're never going to be able to actually develop something practical. It'll hold back the entire industry. And that's where we try to break through, is say, all right, well, what if it could? What if it did work? What if the theory is right? I mean, we look at general relativity, and for the most part, it's done really, really well in explaining the movement within the cosmos. But then you look at wide binary stars movement. You look at the outer edge of the galaxies, where stars start to go faster than they should be at a given distance. It's like there's another pattern here, and so it's kind of like looking at a flat tire and saying, we have a flat tire. Well, very good. The theory has to come in, though, and figure out, why do we have a flat tire? And so what we've done so far is really come up, most have accepted this idea, well, there's dark matter. There's something we haven't seen. So there's a dark nail out there that keeps puncturing our tires. We can't see the nail. We can't find the nail. So it must be a dark nail. And we're getting lots of flat tires. In every single galaxy, there's a flat tire. So there must be lots of these dark nails out there. And people like Dr. McCulloch and others have come up with, well, what if we could come up with a theory that's not just arbitrarily added to each galaxy to fit the data, instead something that actually predicts what the next galaxy will behave like. And his theory seems to be doing that. And so that's like, this is fascinating. So if this does actually make our understanding of gravity and inertia more complete, not breaking previous physics, but rather expanding upon that so that we better understand what's going on in the universe. Once people start to accept that, then they'll start to put more of their effort into developing technology that takes advantage of this new theory. And that's why I say at that point, I think it's going to accelerate very quickly. Very quickly.
I can't wait to see the data that comes back with all of this. And I imagine that you're hoping that you're getting a lot of positive results so that you can move forward with next steps. When you, yeah. And what would those next steps look like if you're getting, I imagine you have potentially maybe an idea of what you would like to see. What would those next steps look like if things were positive or are positive when you get the information back and the data back?
So let me give you an example that you've interviewed quite a few people in these fields, so you probably already have an idea of this. But if we get back positive results that it is accelerating, it is working, then we will have one experiment, physical experiment, that proves quantized inertia theory, while dark matter still has none. I mean, you think about that.
Oh, yeah.
The last 60 years and the billions of dollars spent by really good people, by really smart people working on this. This is nothing against any of the men and women who have been working on dark matter for years. They've come up with lots of different ways to test it, but we haven't had a single experiment that finds it. And so that's the first thing that really excites me, is that if we have proof positive that this works, then we'll already have more experimental positive experiments than the dark matter side of things. And I know that upsets some people as well, but I'm not out to upset any people as much as just, like I said, I'm a practical person. I would like to know what works and move on from there. If it works, then it is going to revolutionize space travel. A number of years ago, Dr. Robert Zubrin, in an interview with Felix, with What About It, which is a fantastic YouTube channel, in it, he was talking about how today it's not so much the race to space as much as it is the race through space. And that got me thinking about it. It's a fascinating analogy he gave with the ocean. There are people who make money by harvesting things out of the ocean, but there's a lot more money made by transporting things across the ocean as a transportation medium. And currently, we're very limited in the means by which any company out there, small or great, can take advantage of using space as a travel medium. So this will open up not only a practical way for us to have interplanetary, interstellar travel, but on an accessible level that all kinds of different companies throughout the world could start using them. And that really excites me. Or in other words, we're really excited nowadays about how high school students, college students, even some grade school students are getting in on sending up CubeSats. They're doing stuff in space. I think that this is going to result in the same kids then being able to send stuff to Mars, or send stuff to Pluto, or go figure out an asteroid. It's like, what's your senior project? Well, it's this asteroid, that kind of thing. That excites me, as well as the commercial side of things. Because as long as you have power, these drives can keep going. And it's not just keep going as in, in space, it will obviously just keep moving, but you can keep accelerating. And that's something that we haven't been able to do before. The main thing that limits travel times between celestial bodies is how long can you accelerate. That's really what it comes down to. So with the quantum drive, you'd be able to accelerate halfway and then deaccelerate the other halfway. If you wanted to actually reach. If you want to do a flyby, then just keep accelerating the whole way. But that's how you can easily get to Mars. I think it's like 44 days because you can accelerate halfway there and then you deaccelerate the other half, and then 44 days later, you're at Mars.
It's so amazing and emissions free.
Yeah.
And having the ability to know that you can have control, right, and how you're accelerating. In my head, all I was thinking was like such a great tagline for a company to say, keep accelerating, because that's that's what it is. And for everybody, for people that are developing ideas, just keep accelerating, always accelerate everything that you're doing. And that's what you guys are doing, which I think is ideal. You're accelerating inventors and people that want to come up with new ideas and think outside the box, but you're actually doing things that are practical, that are accelerating space exploration. It's beautiful. Mm-hmm.
Thank you. And since it is electric based, you don't have to have any exotic fuels. There is no pressurized tanks that can cause issues. There's no extra high temperature sensors and stuff.
With people though, for example, you're having space exploration that we're looking at I forget what launch it was with SpaceX when they just had a whole bunch of people that generally, let's say they're not the average Joe, but they weren't astronauts. And they went up. This is something that potentially you could have the average person potentially fix in space. It wouldn't be extremely high maintenance. So the average person would be able to understand it.
Yes. Yes. In fact, if we start having this kind of interstellar travel, then we will have interstellar mechanics and individuals who can fix things. Also, since it's just electricity that it needs, it can be produced anywhere. In fact, part of, patents have been a part of our process, of course. And in it, we've even put, human generated power. Or in other words, if your solar array battery pack went out on you, you could actually pedal power your way, which sounds really odd, but you could pedal and provide energy to the device that then provides emergency backup power.
It's amazing. You're ever out there by yourself and alone, that's your backup generator is self-powering through a machine.
Yeah, it's an interesting thought. You don't have to worry about, if you ran out of fuel, now you're stranded forever.
Why have we not actually done something in practicality like this before? Because we've had all these inventions for years now.
Yeah, that's a great question. I think part of it is companies do not take the time. And for financial reasons, I get it. A lot of them can't take the time to try alternate configurations with common everyday available things, available products. Because we have this cycle, which for all intents and purposes is very good. But we have this cycle where people go to college, go to school to train for a job because they want to have a job. Well, the colleges then want to train individuals for known jobs, which I get, but then it's a self-feeding cycle, which isn't wrong, but it does dampen exploring new things, especially if there's a mental block saying that configuration will not work because it does not fit my theory. And so I wonder how many opportunities we have missed.
Yeah.
Past with just commonly available. And I know in the space industry, it sounds odd to use commonly available materials but within known space industry, these are things that you can get and arrange. Have to make some of your own yourself. There's no getting around that. But it's not like we invented a new space particle or some weird thing.
Oh, it's practical. It's extremely practical. Yes.
Yes. And I think what we need is more individuals who are willing to say, I'm going to take some time to try it. And I think we need more companies that are willing to say, we have a lot of smart people in our company. We should let them, maybe, I don't know, give them a percentage of time. Like, 7% of your work week needs to be, we'll pay you to work on something that you just think, I don't know, I have an idea, let's try it, and go from there.
I would think though that with specific theories, if you're using a new theory and applying it, I don't know, or testing it out, let's say, that you would start by using common, ordinary things or items that we already know, and then go through process of elimination. That's
Yes.
how I would imagine, instead of going directly to advanced science, because it doesn't mean that the ordinary everyday material could actually it work very well with a new theory. And you're actually proving that right now too, which is really cool. And you don't hear that a lot at all.
Right.
And I wish we did. Yeah, it's sad actually that we don't.
Right. But some people are doing it. And so that's really cool. For instance, this really comes down to a capacitive-based system. And so capacitor is something that we've had around for a long time. Electric fields, E fields are something we've had around for a very long time. But people are still thinking of new ways of working with these things. For instance, you had Dr. Chance Glenn on and talk about the warp drive, and his approach is with a capacitor.
Right.
And that got me excited. But then it goes on to, okay, what if we've actually been seeing the results but didn't know it? So one of the people that really got me onto the E fields and thrust over 20 years ago was T.T. Brown. And T.T. Brown was known for capacitive-based thrust. But today, it seems like a lot of his work was actually just ion wind was the main form of thrust. So it's still a legitimate thrust. It doesn't work in space, but it does work. And I remember making what's known as lifters, just aluminum foil and some balsa wood and high voltage power supply, and it will fly. And it's in Earth's atmosphere. But then it got me wondering, okay, what if T.T. Brown, his work was actually still seeing a small amount of what we think now is quantized inertia?
Interesting, yeah.
And I wonder how many times that it's just such a small thing. Inertial dampening is such a small force that we would only see it proved out in space in a very practical way. And so we've seen it in a similar configuration or almost there all around us, but never actually noticed that that's what was happening, or if that was part of the equation, if you will.
Richard, thank you so much. I hope this conversation inspires people to look at technology and science and just development in a very different light, and looking at it in a practical light too, and hopefully inspires them to go out and try things themselves, or look into these types of theories as well. So thank you very much for the conversation. And as I say to all my guests, thank you for being rebelliously curious thank you for being rebelliously curious with me today.
It has been my pleasure. Thank you very much.